Welcome to a lesson on the difference quotient. The difference quotient represents the slope of a secant line to a given function. A secant line is a line that intersects the graph of a function at 2 points. The difference quotient equals the difference of f of the quantity x plus h and f of x, all divided by h. If we take a look at the graph on the left, f of x is graphed in red, and the blue line is a secant line to the red function. If we let the leftmost point of intersection be the ordered pair x comma f of x. And then from here, if we go down to the x-axis and then write h units, and then go back up to the second point of intersection, the ordered pair for this point of intersection is x plus h comma f of the quantity x plus h. And we can use these 2 points to find the slope of the secant line to derive the difference quotient. Before we do this, though, let's take a look at an animation. On this graph, the function is graphed in black. The red line is a secant line to the black function. The slope of the secant line represents the average rate of change of the function over the given interval of x. So all of these are secant lines to the graph of the black function, where the slopes of the secant lines, again, represent the average rate of change of the function over the given interval of x. One thing to notice here, as h approaches 0, the 2 points of intersection get closer and closer together, and we say the secant line approaches what's called a tangent line. A tangent line intersects the function at just 1 point here, and the slope of the tangent line represents the instantaneous rate of change of the function at a given value of x. So again, the slopes of secant lines represent average rates of change of the function over a given interval of x, and the slope of a tangent line represents the instantaneous rate of change of the function at a given value of x. And here's an animation of a tangent line to get a better feel for what a tangent line is. So the purple line is tangent to the red function at the point of intersection. So now let's go back and derive the difference quotient. So again, to derive the difference quotient, we will find the slope of the blue secant line here on the left using the 2 points of intersection. Recall the slope of a line is equal to the change of y divided by the change of x, or the change in the function values divided by the change in x. So the difference quotient, which again is equal to the slope of the blue secant line here on the left, is equal to f of the quantity x plus h minus f of x, which is the change in the function values, or the change in y. Then we have divided by the quantity x plus h minus x, which is the change in x. Simplifying the denominator, notice we have x minus x, which simplifies to 0, which is why the denominator of the difference quotient is just h. And now let's find the difference quotient for a specific function. Let's find the difference quotient for f of x equals x squared minus 2x minus 3. We need to begin by determining f of the quantity x plus h. To do this, we replace x in the function rule with x plus h, which gives us the square of x plus h minus 2 times the quantity x plus h minus 3. Next, we subtract f of x, which gives us minus the quantity x squared minus 2x minus 3. It is important that we have f of x in parentheses here so that we subtract the entire function. And our denominator is h. And now we need to simplify. Let's begin by squaring x plus h. There are no shortcuts. We have 2 factors of x plus h. We begin by distributing x, which gives us x times x, or x squared, and then x times h, which gives us plus hx. And now we distribute h times x gives us plus hx, and then finally plus h times h, which gives us plus h squared. Combining the 2 middle-like terms, we have x squared plus 2hx plus h squared for the square of x plus h. And then because we have minus 2 times the quantity x plus h, we distribute negative 2. Negative 2 times x gives us minus 2x, and negative 2 times h gives us minus 2h. And we still have minus 3. And then subtracting f of x, we have minus x squared minus negative 2x simplifies to plus 2x, and then minus negative 3 simplifies to plus 3. Let's continue simplifying on the next slide. We have several terms that are opposites. Notice x squared minus x squared is 0. Also, negative 2x plus 2x is 0. And then finally, we have negative 3 plus 3, which is 0. We now have the difference quotient is equal to the quantity 2hx minus 2h plus h squared, all divided by h. But we're not quite done yet. We can factor and simplify. Notice all of the terms in the numerator have a common factor of h. Factoring h from the numerator, we have h times the quantity 2x minus 2 plus h. And then simplifying h divided by h simplifies to 1. We finally have the difference quotient. The difference quotient is equal to 2x minus 2 plus h. One more thing to notice, recall as h approaches 0, the secant line approaches the tangent line, and therefore as h approaches 0, the difference quotient approaches 2x minus 2, which would give us a slope of the tangent line to the function f of x at a given value of x. Again, this will be very important in your first calculus class. I hope you found this helpful.